Okay, let's finish up our work for the semester with the definition of a matrix and matrix operations. If you've ever worked with a spreadsheet, you've worked with a matrix. My grade book, for instance, is a spreadsheet, which is a matrix because there's a series of rows and columns. So it is stated as an m by n matrix is a rectangular array of numbers with m rows and n columns. So we'll have a series of rows and columns, and each particular element points to a specific spot in the matrix. So we'll use our double subscript notation, as you can see here in the matrix, to represent the different elements that occur in your matrix, with the size of your matrix being stated here at the end, the bottom right hand side of your matrix, m by n, which means it has m rows. Always rows come first and columns come second. So m by n gives us the size of our matrix, sometimes referred to as the dimension or the order. So the word dimension or the word size or the word order could be used to represent how big is your matrix. Rows first, columns second. Each of these little double subscripts just points to a specific spot in the matrix. Like A sub 1, 1 means you're on the first row, first column. A sub 1, 2, first row, second column. First row, third column, and so on. Second row, first column. Second row, second column. Second row, third column. So again, it points to a specific spot in the matrix until you get to the A sub mn entry, which would be the last entry in your matrix. So let's first look at these matrices and just state the size, the dimension, or the order. How many rows by how many columns? Okay, come on. There we go. Okay, so for matrix A, if I look at the rows and the columns, I see that there are 2 rows by 2 columns. So this would be stated as a 2 by 2 matrix. The size of matrix B, I see 3 distinct rows, 3 distinct columns, so it would be a 3 by 3 matrix. Matrix C has 1, 2, 3, 4, 5, 6 rows by just 1 column, so it would be 6 by 1. D, 2 rows by 1, 2, 3 columns, 2 by 3. Matrix E, 2 rows, 2 columns, 2 by 2. F, 3 rows, 3 columns. And G, 2 rows by 1, 2, 3, 4 columns. So it would be a 2 by 4 matrix. So first thing is to determine the size of your matrix, the order. Then we'll look at some matrix operations. And we'll have the first few here that we'll look at. First one is equality of matrices. 2 m by n matrices are equal if and only if corresponding entries are equal. First thing we need to notice in this definition for equality of matrices is that they're telling me I'm looking at 2 m by n matrices. That means when I start comparing matrices, they have to be the same size. So that's what that's telling me right here. They're the same size. So 2 matrices that are the same size are equal if and only if corresponding entries are equal. So entries in the same positions have to be equal to each other. Let's look at the sum or difference. If I want to find the sum or difference of 2, here it says it again, m by n matrices, which means I can only add or subtract matrices of the same size. If I want to find the sum or difference of 2 matrices that are the same size, I'm just going to add or subtract corresponding entries, just entries in the same positions. And then a new term here you may not be familiar with is the term scalar. Scalar is a term we use when we're working with matrices to represent a constant. Before we've used the word constant, but now when we're working with matrices we'll use the word scalar. So scalar multiplication just means you're taking a matrix and multiplying it by a scalar or a constant, and to do that you just multiply each entry by that scalar. So we'll just multiply each entry by the scalar. These are just some simple operations, but what you're going to find out is that your arithmetic skills are rusty and you'll make some very, very careless mistakes. So let's look at the next page and perform some operations. So I've got some matrices A through G up here, and let's work on performing some operations. Add, subtract, equality, matrix, scalar multiplication using these matrices. So the first thing is we want to find matrix A plus matrix E. Let's find that result. So I'm looking, here's matrix A, here's matrix E, and I want to add those up. First thing I've got to decide is, are they the same size? And yeah, A is a 2 by 2, E is a 2 by 2, so they're the same size, so I can add those together. Now if I go to the previous page, it said to add matrices, I'm just going to add corresponding entries. So if I look at those two matrices, 2 corresponds to x minus 1. So when I go to add those matrices, I will just add corresponding entries. So I'll have 2 plus x minus 1. Next set of entries, 6 corresponds to 6. So I'll add those two up, 6 plus 6. I'll clean it up here in a minute. Next one, let's look at 0. It corresponds to z plus 3. So this would be 0 plus z plus 3. And finally, negative 4 corresponds to negative 4. So if I add those two corresponding entries, or I should say I would add those two corresponding entries. So the result of adding matrix A to matrix E would be x plus 1, 12, z plus 3, and negative 8. So that would be our answer. Simple operation. Just be really careful with your arithmetic. Well, let me erase all the mess up here, and let's look at another operation. Let's look at, oh my gosh, I didn't want to do that. Hold on, I erased the entries to my matrices as well. Okay, now that I've filled those guys back in, let's look at F plus D. Oh, let's find matrix F, which is here. Matrix D, which is here. And I want to do matrix F plus matrix D. The size of F is a 3 by 3. The size of D is a 2 by 3. So actually this operation is impossible. The sizes have to be the exact same in order for us to add or subtract corresponding entries. We don't have corresponding entries when they're not the same size. So for this one, it's impossible. Let's go on to the next one, and I'll be really careful here not to erase my matrix. There we go. Let's look at 5c. Well, that brings in our scalar multiplication. So 5 is referred to as a scalar. So that means take matrix C, which looks like this, and 5c just means you multiply each element in that matrix by 5. Real simple operation. 5c will look like 5, 10, and 0. 5 times 1 is 5, 5 times 2 is 10, 5 times 0 is 0. Again, it's a very simple operation. Let's look at 3b plus 2f. First, let's look at b and f. Can I add those? There's b, there's f. They're both 3 by 3 matrices, so yeah, I can add them. Now what I'm going to need to do though is multiply b by the scalar of 3, f by the scalar of 2, then add corresponding entries. it's best to write this down because it's so easy to make a careless mistake. So matrix B multiplied by 3 will look like this. 3, 0, 0, 0, 3, 0, 0, 0, 3. It's taking matrix B right here and multiplying it by the scalar of 3. Here's F, and let's take matrix F and multiply it by the scalar of 2. Watch your arithmetic, and you know I may make a mistake and not catch it, but I'm just going to apologize right now for that. So F times 2. Everything in here times 2 would give me negative 2, 6, 12, 0, negative 6, 8, 2, 2, 4. Let me go back and check it. Everything here by 2. Negative 2, 6, 12, 0, negative 6, 8, 2, 2, woohoo, lost a sign, negative 4. Now that we have those two scalar multiplications done, let's go ahead and add corresponding entries. So the final result, 3 plus a negative 2 would be 1, 0 plus 6, 6, 0 plus 12, 12, 0 plus 0, 3 plus a negative 6, 0 plus 8, 0 plus 2, 0 plus 2, 3 minus 4. I really hope I didn't make any other careless arithmetic mistakes on that. I'm going to show you how to do this on your calculator so you won't make any careless mistakes. But for right now, again, please forgive me if I do make any. 2 times F. 2. Okay, well, I'm hoping that's right. Let's look at the next operation. Oh, matrix equality. If matrix A is equal to matrix E, and let me go and erase that part, and erase that. Okay, so we're saying A is equal to E. Here's A, here's E, and if those two matrices are equal, can we find the values of X and Z? And remember, on equality of matrices, it says two matrices are equal if corresponding entries are equal. That means what's in this position has to equal what's in that position. Well, that says that 2 must be equal to X minus 1. That's a real simple equation to solve for X. X is going to end up being 3. And let's look at the other correspondence. Z plus 3 is going to have to be equal to 0. Looking at corresponding entries, X minus 1 is equal to 2, Z plus 3 is equal to 0. So let me set that one up. Z plus 3 is equal to 0. When I solve that, I get Z equal to negative 3. So that was simple enough. Given that those two matrices are equal, I can set corresponding entries equal and solve for X and Z.